fell out of favor, and yet here we are revisiting that technology only now, 80, 100 years later.
Right, exactly.
Okay, can I ask a couple questions real quick? Okay, you said VOC, and what was that again, please?
Volatile organic chemical.
Compound, yeah.
Compound, sorry.
Compound, yeah. But compound and chemical, basically synonymous, right?
Yeah, I was getting confused.
Yeah. A chemical
is compound.
Chemical is any mixture of atoms or molecules, That's really
just like infused in some of the materials, and so you got to just kind of watch what you're getting and where you're getting it from.
So some chemicals are more volatile than others, and all that really means is that molecules of that chemical are more likely to release into the environment just in a passive way. So PVC, which is so commonly used for your drain waste and vent piping.
You can smell it. Like, if you go through the hardware section where they keep the PVC pipes, you're like, ooh.
Or certainly if you cut it, when you saw PVC, absolutely, you get a big heavy dose of that, right? So and those are not good box for us.
Good.
Carpets.
And you just call them box.
Yeah.
Box. Like when we noxious emissions, we call them NOx.
Right.
SOx.
Yes, exactly.
Okay.
Exactly. So
box.
Yeah, you're seeing more and more. Like I noticed. If you go to Ace Hardware now, they're kind of like the kind of middle of the road paint that they're trying to push to homeowners is now a low VOC paint. And even 5 years ago, you had to pay a major premium to get a low VOC paint, for residential.
Good to know.
applications.
Zandy, you also mentioned AHGA as part of the permit process.
Yeah, the authority having jurisdiction is what the AHGA is, and it's essentially your building department and building inspectors, et cetera. And they're commonly it's just referred to as the AHGA.
Okay, and I got one other question you might want to incorporate in your talk. I'm not sure why.
Sure.
But when you were looking at the whole building systems approach, which I really dig, by the way, I totally dig that, especially the water capture. Like, I don't know why every house in Missoula doesn't have a gray water sump or system pumping into their garden, and I don't know. And I think composting should almost be
mandatory.
Yeah. But hey,
the answer to the gray water system is that it's actually very difficult to get the authority having jurisdiction to approve gray water systems in a lot of cases.
Really?
They did use it on the Equinox apartment. Do you know anything about that?
I don't know. I'd like to know. I'd like to know about that.
Yeah, I plan on doing some gray water remediation, and so in my own building here. Yeah. So something that I need to research more. But I know there's a filtration process that goes into taking gray water and basically cleaning it out.
Well, I was thinking even if it was just siphoned into your garden space.
Even that, if the authority having jurisdiction is going to be involved, they will not make that easy. They won't make it that simple.
Yeah.
Anything that's outside the box of what is conventional and sort of published in the code currently is really a challenge for any bureaucratic organization like the authority having jurisdiction.
I don't get it. Okay, and then anyway, my last comment, and then of course we'll get back to it. But according to that slide, I just happened to glance that it in our holistic building, it said minimum carpet. Why would you use minimum carpet? I actually dig carpet. I know that a lot of places like hardwood floor, but I just like the feel, the warmth.
So typically, the problems that we see with carpet is it becomes dusty over time,
and people don't maintain it.
It's not maintained properly. That's right.
Well, you're supposed to vacuum a carpet, according to the guy who sold me a carpet once, twice a week.
Yeah.
Yeah. So how many people do does that?
Who does it twice a year?
There are other issues. I mean, it comes with unless you're buying very carefully selecting carpet that's like low VOC carpet, they're boxing carpet.
Yes.
There is the issue of just dust and dirt and all that, and allergens, and some people are more susceptible to that than others. It's a much shorter-lived finished material than say hardwood or a lot of other options, right?
That's true.
So you're going to replace it
maybe 15 years.
For good stuff, probably depending on traffic and all that.
So and maintenance.
Yeah, so there's a certain amount of embedded energy in it, right? Like any material. So if you're cycling through that more frequently than some longer-lived materials, then there might be a net
it doesn't, it's not so much for comfort, more along the lines of tying in with the sustainability theory.
Usually, yeah, and usually when carpet is selected, like especially in the commercial world, or say residential, like where you're just gonna rent or sell, like you're just, you know, you're not building for yourself, you're building to sell to somebody else or rent to somebody else. It's primarily selected because it's the most inexpensive.
Yeah, my understanding is like you don't want to paint walls and you don't want to pick floors.
Yeah.
For if you're building a house to sell, you paint a very neutral color and you keep the floors really neutral.
Yeah.
But anyway, just for, I don't know.
Carpet could protect the floor, you know, if you have like a sort of hardwood floor, you might want to put the carpet over to protect the hardwood floor. But
I just like the feel of it, you know.
Yeah.
I like to,
Yeah.
I like to get out of my shower and go padding around in my carpet, and I'm kind of freaky because I'm not afraid to push a vacuum cleaner. But
Yeah.
yeah, I think, you know, primarily what they're referring to is like, you know, William was saying, VOCs.
Yeah.
That are typical, the most inexpensive carpeting.
And they are, you do have to replace them.
Yeah,
Look at-
and
look
then
at
what
the
do you do?
carpet.
You just throw the carpet out. There's
Look
no
at the
real
carpet right
recycling
here, right?
process.
Look at this carpet.
Yeah,
Yeah.
this is
So
This
this
one
is
is-
cheap carpet, it wasn't installed, maybe it wasn't installed properly, it's bubbling all over the place. They, you know, the cost environmentally and to the owner of replacing this every however many years, because this is a high traffic area,
Yeah.
is not, it's
Insurmountable.
not sustainable, right?
Yeah,
So-
it's,
This
But
whole-
what you're seeing more and more in this application now, today, is carpet tiles, so that, you know, there are certain.
The
like-
pathway.
Yeah, there's certain pathways here that are higher traffic than like under the desks and
peel them
whatnot,
up
so
and replace them.
replace only those, or you can move them around to even out the wear. So
Excellent.
that makes carpet potentially more sustainable.
That's a good idea. I like that.
That's application.
Yeah.
Clearly, this carpet is past its lifetime.
Yeah. It's like anything, you can choose better or worse materials and better or worse ways of applying it.
Well, I like the idea of starting off with a sustainable material underneath, and then as per, you know, occupants' personal desires, they can put down some other covering. Okay, cool. I was just wondering why. Thank you very much.
Yeah, no problem. So another aspect of mainly energy efficiency is conductivity of the materials that we're using. This is, you know, a list of low conductive materials to high conductive materials in a building. Basically, what conductivity is the amount of BTUs per square foot, 1 inch thick of material per degree of Fahrenheit that it gives off. So insulated materials are relatively low conductivity, and like highly conductive aluminum has a very high conductivity, as we see, and it's you know, 2,000 times what we would see as a typical insulation, and you know, more, 3,000 times insulation materials. This is just one of the things to think about when you're working on design. Essentially, figure out you know, whether this material, like say you're using aluminum stud, for instance, which I don't know if there is even such a thing. Clearly, if you're using aluminum studs, you'd want to put a lot of insulation on the outside of those to keep them from becoming a real conductive heat loss.
I think one of the best practical examples to illustrate this would be like windows, because you know, aluminum window frames have been in favor at times and still are sometimes because of the low maintenance. Sometimes what you see as what appears to be an aluminum framed window or a steel framed window for that matter, is actually just clad in metal, and it's got usually a wood core or a vinyl core or something else. But in any case, there have been, like I have a couple windows in my home that have the entire window frame is aluminum. There is no
Thermal
core of any. There's no thermal break really at all. There's no core of any material with a lower conductivity. So often you're in the position of saying, okay, well, what do I want? Do I want metal-clad windows, or all wood windows, or vinyl windows, and so you might consult a chart like this and really look at a cross section and say, okay, well, it's metal-clad, but what's inside that metal cladding? Is it wood? Is it, you know? And so what is the conductivity of the assembly? Or, you know, it's an existing building. I've got what appear to be aluminum windows with no thermal break. Is that really the case? And if it is, you can see right here that there's a really good case potentially for replacing with something that has a wood core or a vinyl window or something like that.
Yeah, I doubt they even make an all aluminum framed window.
Hopefully not anymore. Yeah.
You'd think that that would just be
Well, I don't know if
such
I'm
an
just,
issue.
I don't know if I'm just hypersensitive, but I like to sit next to the window because I like to read, you know, using the passive light. And so often I'm turning around to see, is this window open?
Yeah,
You know?
because you feel that ghost.
Oh, yeah.
Well, because that's actually convection that's
Yeah.
happening across the glass typically, in most windows, and we'll talk a little bit about that later, learning in it. So embodied energy kind of going on. I guess this should have followed the greenhouse or global warming potential, but it's the embodied energy in the material is all of the energy that material took to produce, and it's incorporated in that material per gigajoule, I think is. I actually have the notes on this.
Yeah, gigajoules is the unit they're using in that chart, which is just a unit of energy like BTUs.
Yeah, so it's not our typical imperial measuring unit, so it's a little bit more complicated. But basically, from looking at this graph, we see that the embodied energy also of aluminum, which is highly conductive, is huge compared to some of these other building materials that we use. I think one thing that this chart might not be completely accurately showing though is that nearly 100% of aluminum is recycled. So that would have a huge impact on the embodied energy of the material in my mind. And I'm wondering if that's properly expressed in this graph. I'm not sure.
Hard to know because the energy that it takes to recycle is also very high. Sometimes generally it's a net gain in terms of energy or it's a net benefit in terms of environmental impact to recycle, but not in every single.
Yeah, it still takes a lot of energy, and it's incredibly intensive to mine the aluminum.
Right, I was going to say, you don't have to extract it again.
Yeah. So my sense is that it's not looking at the mostly recycled content of aluminum and up to 50% recycled.
Also interesting in
steel.
considering that the difference between aluminum and copper is interesting because much of copper is also recycled now, and they're both mined from the earth in similar ways. And I don't know why the two would be so different. It'd be interesting to know.
Yeah, why it's less an intensive process for copper, and I do not know. So right after that would be polystyrene plastic, which we use for vapor barrier, and we also use it in our insulations. Glass, I think that seems pretty high for glass to me, I guess.
That stuff is supposed to be very recyclable.
Well, not so much like window glass, right? So most of the glass that gets recycled goes back into container stuff, or just becomes reused as fines and paint.
Okay.
Yeah, we also find that a lot of the glass that we recycle doesn't actually get recycled.
No,
because it gets contaminated.
Okay.
But yeah, anyway, so embodied energy, another thing to kind of keep in mind, and when we're thinking about the overall building energy usage, we think about how much energy does materials take to manufacture. Yeah, foundations. So this is going into construction types now, and we started out with our foundation since it's the first thing typically that gets built, and some examples of a little bit more primitive styles. I don't think either one of us would suit us today in our climate, but you might see this in an old cabin out in the woods, might be propped up on rocks. There's a fair amount of buildings that still have partial rock foundation in Missoula, actually, too, believe it or not. And some of them are being retrofit, but not only. I'll talk primarily about basement, slab on grade, and crawl space, more specifically when it comes to foundations. Concrete, most widely manufactured construction material. It's used in nearly all foundations. I mean, there's a rarity that a modern foundation isn't chock full of concrete and steel reinforcement. Here you see a more left-hand picture of this guy working with some rebar reinforced concrete. It does need reinforcing with, and typically with steel. Also, wire mesh is used in slabs and stuff. Some of our first buildings, most durable buildings, like this one from ancient Rome, was the first usage of concrete, and realized that it's a pretty durable material from that. And I threw in this modern building that looks like just a concrete pillar. I don't know how attractive that would be to be inside. It has many windows, maybe a line of windows, but you know, clearly concrete is ubiquitous with buildings. It's everywhere. So foundation types, basement, looks like that's the type on there. This basements are very typical in our region. A lot of times they're unfinished, like this picture here, and you see some of the mechanical systems and ducting and whatnot running through an unfinished basement space like this. You know, typically people might want to finish the basement at a later date. You know, a lot of people are turning basements into living spaces. This actually looks like a daylight basement because it has a door that goes out. So it's probably partially open on one side and below ground on the other sides. Basements can be one or more floors that are partially or completely underground. You know, older basements typically weren't very well insulated, if insulated at all. I think you still see a lot of that nowadays. Actually, they weren't even required. There was an exemption for building basement insulation up until very recently in the Energy Code, where people could get by without insulating the basement at all, and it's a huge heat loss because 8 inches of concrete is basically an R1 as far as it's very conductive, not very insulative, and over here I talk about why a basement might be colder than the above grade floors due to the stack effect, contact with colder earth that's got kind of a typically below frost depth. It's going to be around mid-50s in temperatures. Concrete is pretty conductive, and it's going to be bringing that temperature right into the basement. This could be great in maybe a hot climate where you want to get away from it, but you know, in a heating dominated climate like ours, typically not so great. We think typically that basements are cold spaces, and especially the floors, if they don't have a kind of radiant heating system, can be pretty cold. And typically you might put carpet in on a basement slab floor just to keep cold a little bit, or the floor more insulated. Any questions on basements? Slab on grade, not as common in our region to find slab on grade. It gets complicated a little bit when you're doing it in an area that has as a cooling or heating dominated climate that freezes up to 4 feet below the surface. There's a detail here that shows a way to do a slab in our climate with insulating the slab itself and 2 feet of insulation down the thickened slab wall, where most of the load is bearing from the above grade walls, and then 2 feet out. There's different configurations of this shallow foundation type that you can or it's basically a prescriptive way of dealing with it, with typically, foam insulation, rigid foam insulation, and it's listed here. Current code actually specifies that all slabs have to be insulated around the edge and underneath to R10, and this is residential again. And heated slabs with radiant coils, they need to be insulated to R15. And that's just basically so we're not losing a lot of energy through the slab itself. High efficiency buildings will use a lot more insulation to kind of keep that slab isolated from the ground temperatures itself. This is just an example of what you do so that you don't have a frost heave that will damage your slab or your perimeter wall. Crawl spaces, another pretty typical way of doing a foundation in our area. A couple different ways that they build on top of them, either hanging, using hangers to hang the floor joists from the foundation wall, or the crawl space wall, or possibly in the lower left-hand corner here, building the floors right on top of the crawl space. This is the more typical way. The hanger method is a little less typical, but it allows, for a lower floor height, different advantages, usually a little bit more expensive. Some people think that you're saving a lot from an efficiency perspective to get rid of your rim joists right here, which can be a real vulnerability in building by using these hangers. But what I've seen with thermal imager is that these hangers is going to be attached to your sill plate, which is the wood member that's placed on top of the concrete stem wall in your crawl space. And each one of those is not only conducting heat, but it's also a potential air leak. So detailing of how you would properly install a hanger like that is important. And I think most people kind of would just not really realize that from a design perspective. I don't think most people are thinking about that. They just think, oh, it's going to be better because you don't have the rim joist vulnerability. Did I get any comment on?
No, I've never given any thought to that. I think what you're saying is because the hanger has 1/8 of an inch of steel that comes up over the top of the sill plate, that then you have to put some kind of a gasket material over that before you start framing up on top of that sill plate, or you have potentially a little air gap there. Is that what you're saying?
Basically, yeah. From an energy perspective, we think about it as being superior because we're getting rid of that rim. But
I got that part.
But this does have to be, as far as how this.
Yeah. So like this foam tape is critical because if you don't have that there and you put plywood right over the top, this metal is holding that up off the sill plate by 1/8 of an inch, and so you've got places for infiltration.
Yeah, and when I looked at it with my camera, buried actually in the wall, I can see basically each little place where the hanger connects to the sill, and I'm not sure if it's conducting heat loss through the metal or if it's an air leak that is typically.
Yeah, I would suspect more likely an air leak, although, I mean, that foam tape should stop that, but
I think
it's interesting.
Yeah.
But if it gets torn up in the process, then...
Yeah, or forgotten to be applied,
or misapplied, or overlooked,
So that's just one aspect of, potentially the way you build above a crawl space, but, crawl spaces, a lot of crawl spaces, older crawl spaces are dirt. Now code makes you overlap or put a vapor barrier of a certain thickness, vapor barrier or better, down with seams overlapped at 6 inches and taped to make sure that moisture doesn't become an issue down there, as well as ground gases like radon is is be able to kept out of the house. Things to think about when you're building new crawl space. Above grade walls. A lot of different types of above grade walls, depending on your, whether it's commercial or residential, or a mix of both. Get into basically all these different types. On the upper left hand, we're seeing timber frame. Looks like pretty expensive, fancy house.
Nice.
Stick frame, typical, building, residential building also, yeah, pretty fancy, but potentially right underneath that. And then heavy steel frame, commercial skyrise, looks like, a skeletal frame.
I'm currently homeless, they all look good to me.
Yeah, they all look good right now. But, above grade walls in commercial, a lot of them are CMU. This is an example of like a little detail with some insulation of CMU wall. And there's another one here on the right-hand side. You see a lot of box stores that use CMU because it's relatively inexpensive to build with CMU.
And CNU again, please.
Concrete masonry unit.
Okay.
And it's typically 8-inch by 8-inch by 16-inch block, and it's hollow core, and they fill the inside typically with concrete and rebar, and sometimes they leave it open or they fill it with some insulation, depending on what it needs to do. Below that detail is SIPS panels. They look like a 4-inch thick SIPs, which is pretty uncommon. I think you'd have at least a 6-inch SIPs here, but this is an example of them, which is a typically EPS foam sandwich between 2 layers of OSB sheeting, which creates essentially a sheet of foam into a structural member that you can use for a wall section. And this guy's putting up, looks like a 4-foot section. You can build like a whole 20-foot by 10-foot wall out of a single piece of SIPs in a panelized construction method that ends up being fairly efficient because it doesn't have a lot of the thermal bridges that take place when you have wood structural members inside the wall. They're conducting heat a lot faster than the insulation. One other method that I threw in here was just like a membrane, which is not real common where we are. And I'm not exactly sure what that building is made out of.
I think that's like a Quonset hut ribbed steel type structure.
Okay,
looks like an ice rink or something probably.
So you think it's steel? Yeah, I was thinking. I think it might. I thought it might be a membrane. So I was just like, yeah, that can be done. People, yeah, I mean, it's kind of like a steel building, but there's different methods of walls. Clearly, that it really depends on the function of the building and what might be most cost effective. So steel framing, we're typically seeing this in more commercial buildings, but there's an example of a residential light steel frame building here as well. Like I was saying before in the conductivity chart, steel is highly conductive compared to wood material. So when you're building out of steel, even though it's a great durable building material that questionable embodied energy because of the amount of recycled content that it has. It takes a lot of insulating and typically like a thorough insulation coating the building rather than cavity insulation like you'd see in a stick frame or a wood frame building because of how conductive the members are. You could have some real condensation issues in our climate if you weren't addressing the conductivity of the steel itself. Not real common here. This is a detail of how to insulate the outside of a light steel frame building. You see the steel studs and Yeah, this is polyiso, the thicker stuff with the atlas on it. I think this is probably the manufacturing company's detail. I cut out what they're saying here because they didn't have room, but yeah, it's kind of like a typical thing that they'll put little sandwich insulation all around the whole building between the siding and the sheeting on the building. So got a lot more embodied energy when you think about all the insulation that needs to go into a steel frame building. See on your concrete masonry unit, like I was talking about before, it's really inexpensive, easy to transport, easy to build with. If you've seen anybody building with them, they slap them up there and then put some grout, and you slap another layer up, and it just goes. You see a box store being built in a matter of weeks. I was
going to say commercial industrial.
Yeah,
I've seen it for that.
It's so common in those buildings because it's just really cost effective for them to build that way. Not only that, but a lot of these buildings are made to look the same, whether it's here or in Arizona. It's an easy way to kind of accomplish that. Though with the new commercial building efficiency code, I wonder if there's going to be any change in that, or if they're going to start covering the exterior like they show on this detail. It's got kind of a rock facade underneath the insulation that they're using. The new concrete, our CMUs are also insulated on interior by using standard wood frame walls. Are you got anything else you want to say about it?
No.
You don't see it too much in residential. Insulated concrete form, or ICF, fairly typical material for higher efficiency building. A lot of times we'll use it in a foundation like you're seeing here. It's a way to get your foundation from the start. You don't need the forms that you need to build the concrete wall with, because the insulated concrete form is the form you use, and you just stack them in blocks, and then you put your rebar in there, and you pour your concrete right in the center. It's usually 2.5 inches or so of EPS or XPS on the exterior side, like you're seeing this detail here. Which creates between usually like an R21 to 25 or 26, depending on the type of foam and the manufacturer. They tend to be really airtight. They're very quiet. Some people like to form with these because they say it's faster than forming with another way, and then you have your built-in insulation. I think it's pretty good material for foundations. I kind of start having issues with using it for your whole building, because again, you're not getting away from the petrochemical insulation that's covering everything.
Yeah, it's a good option for do-it-yourself or do-it-yourself home builders who want an efficient home, because they don't likely own all the forming materials to
or have the skills. I mean, that's another step. In some ways, anytime you can skip a step, you're saving yourself that much room for error.
Yeah. One problem that they do have sometimes with these, with inexperienced builders that are using it, is that they have a hard time keeping them straight. So you got to take a lot of care to making sure that your wall is put together tightly and it's really straight and flat.
Which is really true of any forming technique. And this one does those plastic webs you see between the insulation material are kind of designed so that they're little slots to lay your rebar into. They make it in a lot of ways easier to get all your reinforcement set up evenly spaced.
That's true.
Another consideration though too is usually the authority having jurisdiction will require, for instance, like a fire barrier on the inside of a foundation or crawl space, basement or crawl space wall.
Will that mitigate some of the VOC?
No.
Because they're still going to be on the interior.
They can still get through the sheetrock to some extent. Okay. Yeah, and sheetrock is usually the fire barrier that people will use. Although there's some other materials that are applied with like spray on or brush on kind of
That's a good point that I didn't bring up, that, yeah, most foam insulation needs to be covered in where it's in a living space, which means that you can get away with it, I think, in a crawl space being exposed.
Not in some recent projects that I've had that I've worked on, where around here the building inspector required sheetrock on the crawl space walls on the inside as well.
Really? Okay, that's interesting. So maybe that's a newer thing. I was pretty sure that, maybe not, or a little bit longer ago, that it was just basically in any place that was considered a living space that it needed to be covered. But then I remember that spray foam, closed-cell polyurethane needs to be covered too for the same kind of reasons, and there's different ways of kind of doing that. You could even put in fiberglass bat on top of some of the stuff to create that fire block. So another kind of newer manufactured panelized building material, structurally insulated panels, is or SIPs, which I showed you earlier. You know, pluses are the panelized construction is fast and efficient. And the polystyrene foam has very high R values, and they can be very airtight. You want your building to be very airtight when it's a SIPS building. I'll get to that, as in this picture down below here. Yeah, the minuses, which I'm quick to go to, is it's high global warming potential and embodied energy in the foam itself. The OSB can also have formaldehyde in it. I think we're kind of getting away from that nowadays. It's with more modern products trying to get away from high VOC materials, but you know, it's glued together essentially. If a SIPS panel is site modified to do whatever, like they made the window opening too small, so let's cut it open. That can be kind of hacked up, and then we start having some more potential issues with air leakage. These are built to be, usually the factory manufacturers gives you the tape or the sealant that goes along with the SIPS panels to make them super tight, and so that they don't have the potential for issues like I'm showing down here. But if they aren't perfectly airtight, what can tend to happen is, we call this like roof rot here in the SIPS, is that all your warm air rising as it gets lighter and hitting the ridge. The ridge is a vulnerable spot. If they say, for instance, they site cut that ridge, and they didn't do it in a way that was really mindful of, maybe they were using an eye joist in there that they're sandwiching the ridge up to, and they didn't cut around the webbing. So as you can see in this detail, there's it's kind of like a narrow slice on the edge there. That's so that it fits around the structural members that this panel is butting up against. Basically, has like maybe a 2x4 or something that would hold it together on the ends. Very important that be super tight and form-fitting where it connects. When it's not super tight, form-fitting, and they made a mistake with the sealant or the tape when they're putting it together, this can happen. And it's happened on a number of SIPS roofs around here. Typically, it's the roofing is the problem, is because, you know, like I said, the warm air rises and it's going to sit up there. When there's a point to leak and there's a cold surface on the top of that OSB from the exterior temperature, there can be a condensation problem. There can also be a bulk moisture issue from the roofing material not being adequate, and it causes the same thing. But typically, we see this issue from during the heating season, when we're heating the indoor air temperature and that heat's rising, and then it's condensing in some really unfortunate places. And this other detail right above here is also kind of showing like where that moisture is building up between those panels. Not a good spot. So builders that know what they're doing with SIPS panels, I think they're very mindful of that, making that really tight and airtight and watertight, moisture, getting a good moisture barrier in there so that warm air doesn't migrate up through those panels.
That's important inside and out, like from on the inside of the attic and the
yeah, I say from, you know, and typically if you're building with SIPS, since your SIPS is your insulation layer, then there is really no attic. You have like a vaulted ceiling. Right. That's the bottom of the panel. Okay. And then, you know, that panel is basically all of your insulation and your roof. And so, you know, without a vented attic, like per se, if moisture gets in there, it's not dissipating, and it gets underneath. You know, like in this picture, it gets underneath the roofing material. I see. And then moisture does bad things to this. Basically, just comes apart like cardboard. Okay. After it gets damaged. Stick frame, probably the most common method that we see for residential. You know, it's all the trades know it very well. There's a lot of people that know how to frame and have their own methods for framing. Relatively inexpensive for residential sized buildings. And you can balloon frame. Balloon framing is a stick frame kind of method. It's a little bit outdated. Most of this balloon framing was kind of a traditional way of stick framing with no real platforms to build on. So you put up if you put up a 2-story house, you put up your 20-foot wall, and then you tack your second floor floor joist right to the studs, like in this picture here. And then they're supported. And the nice thing, I guess, about balloon framing is you can have a very well-insulated cavity that doesn't have, say, the rim joist vulnerability in there, which would be like a platform where you have the first floor and then you have the top plate, and then you put your floor joist right on top of that and your rim board right across that, and you have this big lot of wood right there. You can avoid that by doing the balloon framing style and just tacking it right to the wall. What tends to happen in older buildings is they're under insulated, so that balloon frame would just basically be this chase for air to conduct and take the heat out of
one floor to another?
Well, right out through the attic. So, you know, basically the heat, the cool air is being pulled
almost like a duct.
Well, yeah, I mean, it's like basically if it wasn't filled with insulation, then it was a pathway for airflow with convection, you know, the stack effect creating this draw of warm air rising. And if there was, you know, typically leakage at the bottom and leakage at the top, which is typical, you know, in older buildings, then yeah, you're losing a lot of heat through there. Modern high efficiency buildings are actually, they're using balloon framing because they can very thoroughly insulate, like I was saying before, that layer, and there's not a lot of wood in there, like in platform framing, that can cause a conductive heat loss issue, thermal bridging, essentially getting away from that in the balloon frame. Again, you can use the same method for either inefficient building with a lot of leakage or very well insulated and very airtight for a very high performance building. It's kind of coming back in practice. I threw this one in here because I think it's an important part of sustainable and building efficiency, and it was also in the book. It's advanced framing method is basically a way for builders to use the least amount of wood in a wall stacking everything up so that all the loads follow, straight down to the foundation. Is an important part of the advanced framing method, so that the loads are transferred properly, because there's less wood in the wall to actually hold the load. This section is shown that the exterior walls are framed at 2 foot on center, which is not typical framing. Typical framing would be 16 inches on center. But they're showing how the weight from the roof follows down through the frame, through the platform and everything. All the members are lined up, so you're able to get by with less structural members and accomplish the same thing. And the benefit of less structural members is that you have more room for your insulation and less for fairly conductive structural members. Wood might be a lot better than steel from a conductivity perspective, but it's still only are like 1 1/4 per inch, and not near as good as even your cellulose at 3 an inch. You'd rather have cellulose in your walls or other forms of insulation than just a bunch of studs. So in a lot of buildings, you'll see that maybe they're using some advanced framing methods, and then they're not using all of them. This one is basically a conglomeration of like all the different framing methods with no cripples. We're showing under the windows. There's just a single king stud around the openings, and they're able to hang headers with the same kind of metal hangers that they use for like hanging your floor off a foundation wall, or same kind of hangers they use in attic or in a roof assembly to hold a rafter or something like that. So it basically holds that member in place without having another piece of wood taking up space in that opening, in that wall. I think, and then raised heel is another aspect of this, allowing full depth of insulation through the attic. It's not necessarily specific to advanced framing, but another, basically the idea behind this is that we're thoroughly insulating the house, trying to minimize thermal bridging through the structural members, and at the same time we're reducing our lumber usage. So it's
I like it.
Very beneficial way of efficient building. This is kind of a conglomeration of different very high efficiency wall structures. These are pretty much, most of these are built to passive house standard, which we'll get to in a future class.
These are maximizing insulation?
Yeah, basically the idea behind these is that they're allowing for a very thick cavity to fill with insulation, like a low global warming potential, low embodied energy insulation. Unlike foam, like cellulose is one of the really lowest on the scale, which we'll get to at some point. If you can fill this wall with cellulose, you can you get a very high R value with a thick cavity like that, and use cellulose, which is really inexpensive, nearly 100% recycled, and very, very low global warming potential and embodied energy. So double stud wall, fairly common method that actually you see in our area to accomplish this kind of thick cavity. Also, most people are familiar, most of the trades are familiar with framing a single wall. So a double stud wall, basically framing 2 walls to create a single thick wall, is something that most framers can wrap their heads around. Other ways of building this cavity is using a truss wall type, either Larson truss wall, which is a non-structural truss, essentially just a cavity for your insulation. that you're building onto your building. This is a retrofit actually out of Fine Home Building that showed how you could tack this onto your existing siding, this Larson truss wall. Hopefully you have a large enough roof overhang that it's not an issue. But you tack this on and then you just fill those cavities full of cellulose or some other kind of fiberglass insulation, and greatly benefit from the building or the efficiency performance of that after you do it. Larson truss can be basically used or built out of scrap wood material from a site, little pieces of sheathing and chunks of 2x4 and stuff. Since it's not structural, it doesn't necessarily have to be perfect condition new lumber can be used. Another benefit of the Larson truss wall. Another way of accomplishing Larson truss wall is also using a TGI, which is a wood eye joist essentially, to create those cavities in a wall and building a wall out of the eye joist. They're typically used for RTGIs or BCIs that are typically used for floor framing. Structural truss wall, basically a beefed up version of Larson truss that is able to hold the structural load of the roof. And so it's got to be built in a slightly different way and engineered to hold all the way. Not very common. A lot of engineers have a hard time, structural engineers have a hard time, I think, wrapping their heads around how they build this custom wall. But it's another method for high performance building. Exterior rigid insulation is one of the most common ways of accomplishing a very highly insulated wall structure. Also avoids the bridging potential of the structural members on the inside. The whole wall structure is wrapped in this continuous layer of insulation. Like I said, preventing thermal bridging. It's also in this diagram we're seeing the slab well insulated and the foundation wall well insulated as well to prevent heat loss through the slab, through the foundation wall. The connection between the slab or the foundation wall and the upper walls is a real issue as far as air leakage and conductive heat loss, thermal bridging, because usually there's a seam there and a structural member that's taking up the space where there could be insulation, or where there should be some insulation to thoroughly insulate. So that's it's one of the primary focuses of passive house and high performance building, that they don't have too much thermal bridging at that point.
And air leakage.
Yeah, there was a design I was just talking to a local architect about. That was for passive house, and they put 2 inches of insulation around this whole wall that was already nearly 2 feet thick of cellulose. And I was questioning why he needed to have that much, exterior rigid insulation on the building, and he said it was all about that the sill plate, essentially the conductive loss through that sill plate was enough that it needed more, and it didn't make a lot of sense just to put a strip of foam around the whole kind of rim of the building, because then you'd have to have some kind of fancy flashing, and it'd look weird, right? I mean, maybe you could have built it out with rock work or something like that, but it made more sense to make the whole wall that thick, and cover the whole building in this, high global warming potential, high embodied energy insulation, instead of just trying to deal with the sill in a different way. There's other ways of dealing with sills, and we'll get to that stuff later in lectures too. I'm close to time. Rain screen's really common in more in wetter climates than it is in ours. You don't see as much of a bulk moisture issues in Montana as you do in some places. But it's a good idea, especially when you're building a really thick wall that you you don't want to get wet from the outside. Allowing a plane where air can freely flow from the bottom to the top. So open at the bottom, open at the top to airflow, and basically any moisture that gets through the siding has a way to dry out rather than start to rot your sheathing and your wall out. Of course, a building wrap would be the primary way to protect your sheathing layer, right, and your wall from getting wet from bulk moisture besides the siding itself. But this allows a cavity so that it functions a little better than just pressing your siding right up against your building wrap and having no cavity for airflow there. So any moisture that gets there could get trapped and eventually could get through your building wrap and start to damage your wall.
I'm skeptical how many folks know how to do that properly.
What, this rain screen?
Yeah.
It's really pretty simple. They use little battens like they're showing us.
I see it now, but I see a lot of construction that doesn't.
Yeah, you don't see this as much in our region because most builders think this is overkill. I mean, this is obviously an extra expense. And look at the flashing detail on the right there. It gets pretty involved. Most builders around here feel that it's not, because it's not required, and we don't have that wet of a climate typically, that it's not necessary.
But, I mean, I see the wrap. I just don't see I don't see it done properly. And so in some ways it's like, why even do it?
Yeah, if it's not done properly, then it's a waste of material and time, obviously. And I'm sure there's a lot of times when it's not done properly. One mistake that you can make is actually you can mistakenly tie that little airspace into the venting for your attic through your soffit, for instance. And so you accidentally get that airflow to go up and then into your soffit that's supposed to be removing the moisture from your attic, right, venting your attic, and it's actually just drawing in all the moisture that came through your wall into your attic.
So if it's not done properly, it's even worse than not doing it correctly.
Yeah, so I would say that would be probably worse, and you might have some mold issues in your attic because of that instance. So it's important, detail it properly. Again, not super common. So roof assemblies, a lot of different kinds of roofs, types out there, depending on if it's residential or commercial or what the customer wants, whether they want to have it look like a barn or modern butterfly, able to actually collect a lot of rainwater when it's opposing like that, the reverse of the gable, I guess. Shed roof, also another kind of common type, used with more modern building too. Flat roof, more common for commercial buildings than residential. Flat roofs tend to have membrane type roofing materials that are expensive and need to be done right as well. Main types of roofs are roof assemblies are either vented or unvented, and I kind of go into that. This is a little detail of how your unvented roof assembly is basically any moisture that ends up going into that is not going to go anywhere but rot the thing out. So you want to be really careful. Either one of these, you don't want moisture and warm air to be flowing in sort of the heating season to be flowing up into your roof assembly. But at least if you're venting a roof assembly, which is pretty common here, you've got a little bit better safety measure for any moisture that might get in there than if you decided not to vent that space.
So it's kind of, there's definitely considerations that I'm assuming you'll go into on which roof is adequate for all the different factors.
Yeah, yeah, and I go into that a little bit. It's it's hard to go into like everything I'd love to go into,
Mm-hmm.
but we will get into, I'll get into a little bit now, but into a later date, we'll go probably into more detail about moisture management
Mm-hmm.
in
Excellent,
particular.
good.
So the pluses and minuses with all these different assemblies, you know, metal standing seam is a great product. I think probably the biggest problem would be that it's fairly expensive.
Mm-hmm.
But, you know, it's super durable.
Mm-hmm.
The fasteners are not exposed, and so, you know, they tends to last, you know, virtually forever. They're properly installed,
Mm-hmm.
You know, properly vented, of course, too. And that when they're at the end of their service life, they can be recycled. Probably the most common, asphalt shingles, produces 11 million tons of waste in the United States every year. So, you know, have a way to recycle them would be great. Right? I don't really think of them as a sustainable way to do your roof. It's just the least expensive, kind of easiest way to deal with modern roofs. And for residential, you see it most commonplace. They can be toxic to the water runoff as well as being an issue with what do you do with them when they die in 15 to
Right.
50
And
years
they do.
at the longest
Yeah.
warranty process. And they
Right.
do, yeah, of course.
They last less than my carpet.
Cedar looks great. It's really pretty. Can be fairly expensive way to, or cedar shake can be a really expensive way to roof. Also can be a fire hazard in some areas. Typically there's some kind of fire coating on a roof shake for cedar, but yeah, I mean, I think primarily people stay away from shake because, you know, it's not a super long lasting roofing material. You know, it does pretty well, but it's really expensive for, you know, just the benefit of it looks really nice. Slate, another really expensive building material that you don't see too commonly here because there can be issues with
Those buggers are heavy too, aren't they?
slate.
Yeah.
Yeah, I think it's relatively heavy. It's basically rock,
Mm-hmm.
and not a lot of people know how to install slate around here. But also, I think it can be an issue with cold weather, frosting and cracking and whatnot. Tile, you don't really see any of that here for some of the same reason. Though because of the way that it lays, it's able to shade itself and create a cooler roof. And you see it a lot more in some of the warmer climates. Membrane, typical roof for roofing material for flat roofs. You know, more commercial. It's expensive. This is a TPO style, like vinyl, but they also use a rubber EPDM membranes pretty commonly. They typically have some kind of ballasting material up there to protect them from UV, like a rock, gravel. Metal roof, super common, a little bit more expensive than asphalt. You know, the typical metal built roof has exposed fasteners because of the way that the metal expands and contracts in relationship to wood differently. Tends to move around through the heating and cooling seasons, and the fasteners tend to make kind of these elongated holes, and eventually they start to leak usually, and they start to, actually the screws can like come out from that movement. So it's the kind of roof that I got on my house. Didn't want to pay the extra bucks for the standing seam, but I really wanted it. It was ridiculously more expensive, so I ended up going with that. I'm kind of just mindful of the screws backing up. The fasteners have kind of a protective sheet of metal over the top of like kind of a neoprene washer that has a adhesive that's like glues it to the surface. So that's supposed to prevent it from, you know, they're supposed to make it last years and years, hopefully. Living roof, pretty uncommon around here. Pretty expensive way to go. It's got a lot of benefits for green building. It's nice to look at. Keeps your roof cool. Tends to be pretty complicated how you build it, and can be heavy. There's ways of building them that don't use as much dirt. Use a different kind of. They don't even use any dirt. They just kind of use this foam pad that allows them to be really light. But they do need to be irrigated sometimes if we're super dry to keep them alive. I actually put one on my chicken coop, and it's got cactus up there that just love it, and they've kind of taken over. That's cool.
I see a little slope on that green roof. Is that, I mean, how much slope can you get away with?
So that's a good question. I don't know how much slope you can get away with, but when I was researching this for the lecture, I saw that there are some fairly sloped green roofs out there, and I think you'd have to kind of terrace it a little bit if you're really sloping. I think most commonly they're fairly flat. You don't want it to wash everything off, but they can be built in different ways. Like I'm talking about that kind of pad that they use. It would seem like that would work fine on a more sloped surface. But what I think you'd see is like the kind of water flows down from the top. Everything at the top is going to get all dried out.
Right.
So
there must be some optimum there where you're not too soggy and not too dry. Maybe.
Yeah, I would think there would have to be a little drainage. Would there?
Yeah. Well,
No?
it drains all the way around. I mean, the drainage isn't really an issue. They built it so that it drains easily, but you just don't want the water just to run off immediately, because clearly, the plants that are living on it need the water to survive.
I guess my concern, and of course, I don't know from Shinola, is that would be the opposite, that you'd have pooling areas.
Yeah, you don't. You want it so that whatever the membrane is, or whatever that's the moisture barrier up there, is not cupping and basically pooling water, but it's built in a way that the water all flows, just like any other roof. You want the water to flow off of it. It's going to flow in a certain direction.
But you don't want it to just sheet off.
Yeah, exactly. You don't want it to sheet off. And typically, I think probably for the purpose of growing on it, that they are fairly flat. But like I said, when I was doing some research on this, I saw some fairly more steep roofs than I've typically seen. I think it's still an emerging technology, even though you see some really old buildings that are basically this moss mat.
People have been doing it for centuries.
Yeah.
Saw everything from sod to.
Well, I'm intrigued, but at the same time, but I'm also skeptical.
I was going to add a detail of one of the green roofs with more modern materials now, but I decided that was too much for this lecture. Now running overtime, but it definitely is. Roof assemblies, I'm really focused on the rafter and the truss. Basically, the two types of assemblies we see mostly around here. There's an assortment of different truss styles. Almost all modern roofs of commercial or residential type are made out of roof trusses like this, either metal or wood. The example of a raised heel truss, like we were talking about a little bit earlier, where it allows for full height of insulation over the top plate there. So the point where you're going to be losing your most heat around the edge of the building there is well protected. And then it also has a baffle that goes up and around the insulation, allowing soft airflow to go up and vent the attic properly. It's all part of the combination of making that work out. I guess the difference between the rafter and the truss is the webbing, primarily. In older buildings, you see more rafters are kind of like a custom truss or a rafter with a collar tie, like in this picture, and a ceiling joist, and that's it. There's really no room for insulation where it bears on the walls around it. There's the top chord of the rafter is fairly unsupported, so you can only build, you have to have a really huge member to hold the weight, as opposed to truss, you can get by with a much smaller member, typically 2x4, with this kind of webbing I'm showing a picture of. You can get by without having to have a huge beefy truss, or huge beefy rafter supporting all the roof weight.
The big difference was, do you have a crane to lift the trusses on the roof, up onto the roof or not? If you don't, you build with rafters, and there are different ways to reinforce that with collar ties, and you can even install webs in place, frame it in place, just like a truss.
Yeah, I actually built a custom truss for my roof because I didn't want to use a huge thick rafter like was done. I added on to my house, and it was interesting. I just followed this guide basically on how to support it with custom web. But yeah, if you're out in the woods and you don't have a crane to lift your roof truss, you're probably not going to have someone delivered out there either.
Or even just before 1960.
Well, so that might have been more common a while back.
Oh yeah. And a lot of those, like a house like mine, smaller craftsman kind of bungalow style house, still 2x6, sometimes even 2x4 rafters, but hopefully with collar ties, maybe a ridge beam. Sometimes it still makes sense to frame with rafters.
There's a couple of different, basically, we talk about roof assemblies, we're talking about vented or unvented, and this is some examples of a vented style. Actually, this is an example of an unvented style over here too. But basically, either if you have a cathedral vaulted type ceiling, or if you have an attic space, most people in our area want to build with a vent cavity so that they can mitigate ice damming and moisture issues, easily. So most roof structures that we see, both commercial, I think, and residential, are vented, and they make it easier to properly or to mitigate moisture is the main thing. But also ice damming can be a problem, and I'll get to that in the unvented roof assembly. So if you want to do an unvented assembly, you need to follow table R 806.4 of the IRC and find out how much insulation that you need to have to prevent potential condensation and ice damming issues. Clearly you need more insulation when you get into some of the colder areas of the states. Again, if you're going to go with an unvented roof assembly, you're kind of taking kind of building science in your own hands, and you better make sure that you are keeping the moisture from migrating into that assembly, and keep the bulk moisture from entering, from outside from your roof into that assembly, because once it gets in there, it's not going to come out. It's just going to rot your roof structure. So in unvented roof assemblies where it might not be convenient to vent the assembly, special precautions are taken to make them very airtight and the proper insulation levels so that snow doesn't melt up there and then turn to ice.
Do you understand the concept of ice damming, or how that forms?
No, tell me.
Familiar to you? So if you look at that, see the eave down there? It's kind of, it's further away from the warm interior spaces, right?
Okay,
so its temperatures are going to be closer to the outside temperature.
Okay, so it's going to build up a berm.
Yeah, and so if your insulation is, your insulation is not perfect all the way up through that roof assembly, right? So you're going to have heat from the building migrate up through the roof, conduct through that roof assembly, and melt the snow that's up above, and that's going to run down and potentially freeze on the eave. And when that happens, like you said, it starts to build up an ice dam, and then as more snow melts above, it can actually back that water up behind the ice dam, and then especially if you have like asphalt shingles or any kind of lapping type shingle, it can work its way up underneath those laps, then down into the where the sheathing is, is
And it'll actually
work its way,
wick its way.
or even drip its way into the places you don't want water or moisture to be.
Yeah, I realized I should have put some pictures of ice damming in here and some, some poor details of insulation, more typical insulation details than this one, which is a very thorough insulation method of that area, trying to prevent any potential for ice damming. But yeah, ice damming can be hugely damaging to a building. There's a problem with the insulation in a building up Grant Creek. We did put some solar modules on, and basically their metal roofs is just getting torn to crap.
Some of the older buildings are the most, the ones that have the poorest insulation are the most beautiful in the winter, though. I mean, you see 6-foot icicles hanging off.
Yeah.
Yeah, like my house. It's not so great. Yeah, that's a sign of a problem, unfortunately. So we're totally out of time now as we run way over, but I don't know if there's any other questions that I might be able to answer.
Did you get my corrections to my mistakes I made in the?
I'm going to wait till he turns off the recording.
Yeah, let me kill the recording here.